Good morning to all. Myself Dr. K. Manoharan, Associate Professor, Department of Biomedical Engineering. So today class we are going to take a case study topic on digital thermometer and temperature control using 8051 microcontroller. So first thing we need to have a measure a temperatures. So for that we can use a manual methods or we can use available temperature meters. So we need to find that what are the drawbacks and we need to identify that how we can improve this. First thing, so we need to have an accurate temperature measurement for an health hospitals, industries, and for environment temperature measurement also. So for that, we need to have a digital thermometers. So the traditional thermometers are very slow. Again, it has some errors. So we need to eliminate this. So digital thermometer will be high precision and high faster and it gives an real-time readings. So that's why we go for a digital thermometers. Look at the sample image of digital thermometer. So the problem statement is, we need to have an avoid the manual reading because whenever we are doing it manual reading, we cannot have some automations. So manual temperature reading, it gives an manual values. We cannot have an automation using that values. So for example, we use in incubator or freezers, so the manual reading cannot do any information. So that information can be given to only users. So we cannot include an alert or a control mechanism based on the temperature higher than that particular threshold, or we need to have an alarms. So our problem statement is we need to design a low cost, again automated and user friendly solution for the temperature measurements. So this is our problem statement. So our objective of this case study is, so we need to measure a real time temperature using this temperature sensors like an LM35 or we can use any temperature sensors. Look at this. So these sensors we need to measure a real time temperatures. So after that measure that value, that information to be displayed using LCDs. So we can use a standard 16 cross 2 LCD or we can use a 20 cross LCDs to display that information. So we need to implement the temperature based control like an fan, buzzer activation, or we can inform that information to the users. Look at the block diagram of the system. Look at this. This is the microcontroller 8NC5 I am taking here. I am taking this is an ADC. So here I am going to connect a temperature sensors LM35s. So we need to have the temperature sensor. So that will be in an analog output. That analog input should be converted to digital. That's why I am going to use this ADC. So this is an 8-channel ADC. I can connect an 8 different temperature sensors also with this ADC. So here I am going to connect with this port 3. Also this is the control lines. So this is for an start of conversion and end of conversions that will be connected here. And this is an LCD interface. So this is the data lines and this is the control lines. So enable signal, read write signal and register selected. So these control signals and this is the data signals and this is the VCC supply and contrast controls. So here we have a crystal connection and this is for a reset circuitry. So what we do, so we need to measure a value from a temperature sensor and we need to convert a digital form and that should be given to the microcontroller. So microcontroller process and that information should be displayed in the LCD modules. For example, if you need some buses or an alert information, so that also we can connect with another remaining ports. Look at the coding parts. So I am going to include this register 51.h because we are going to use an 8051. So that's why I'm including this register 51 header files. So main program void main. So unsaid integer temperature I'm taking. And first I'm taking a function LCD initialization. So LCD initialization function I'm calling it. So this is to be done only one time. That's why this is outside the while loop. So while of 1. So why we are putting a while of 1? So these things should be done repeatedly. That's why I'm putting a while of 1. So while of 1 means it is always true. That means what are the inside this loop that will be executes continuously. So I'm taking this temperature equal to read ADC because the sensor output will be connected to ADC. The ADC output will be the actual temperature. So temp equal to read ADC. After that I am converting into Celsius. So temp equal to temp into 500 divided by 256. So this is the value I am taking it to the Celsius. Why 256 means this is an 8-bit ADC. After that, I'm going to display the information. So I'm just calling this LCD display with temp. So LCD display is a display function. What I'm going to display, this temperatures I'm going to display. That's why LCD display with this variable temp. So this value is I'm displaying the information. So here I have read the temperature and displayed the temperature. What I'm going to next, so whether the temperature is greater than that particular threshold, I'm going to check it. Look at this. If temperature greater than 40, if the Celsius is greater than 40, I'm turning on a buzzer. So buzzer equal to 1. So the buzzer is turned on. Else the buzzer equal to 0. The buzzer is turned off. Even we can take some other task also. So for example, we can have a multiple threshold. For example, greater than 35, greater than 40, greater than 45. Each one we have a different operations also. Look at these results. So accurate reading from a 0 to 100 degrees Celsius. So buzzer triggers that above set threshold. So once that threshold crossed, immediately it alarms the buzzers. It can be calibrated for an medical application, industrial and food grade and environmental applications. Thank you.